Hey guys, welcome to lesson 2.6. In this lesson, we're going to talk about inequalities. So first we're going to do example 1. In example 1, this is should be mostly a review problem. So we're going to talk about solving inequalities by hand first. Excuse me. So I'm going to start here with A, where I have f of x equals g of x. So I'm going to take my f of x equation, 2x minus 1, and set it equal to my g of x equation, 5, and solve. You guys are really good at these ones, setting things equal to each other and solving. Beautiful. So let's try an inequality. Now I have f of x, 2x minus 1, but now I want it to be less than g of x. I'm going to do a less than 5. So I go through and solve it again. By the way, a little reminder that if you divide by a negative number, your inequality sign will change directions. We don't do that here, so we don't need to worry about it too much. But we solve, we get our answer. Last one, let's try a greater than. So we have the f of x equation is greater than the g of x equation, and we solve. We aren't dividing by a negative, so we don't need to worry about that. We get that. But more importantly than knowing how to do this, it's really important to know what these answers are meaning. So we're going to take a second and visualize what is going on with these two equations. So we're going to start down here. We're going to graph our two equations. So I have f of x is 2x minus 1, so my y-intercept is minus 1. Slope is up 2 over 1, up 2 over 1, up 2 over 1. That gives me my f of x. I'm going to connect all those to make a nice, pretty f of x graph. G of x is g of x equals 5, so that is a flat line at 1, 2, 3, 4, 5. So flat line at 5, there's g of x. So let's start right here. F of x equals g of x. Equals is the same thing as an intersection point. So if you come down here to these two graphs, you'll see that they intersect one another here at this point. And this point is 3, 5. That is where this x equals 3 comes from. This is the x value of the intersection point. So anytime you are setting two equations equal to each other and solving, you're actually finding where those equations intersect each other. So now let's talk about less than. This is x is less than 3. So if I look at x is less than 3, here is my f of x graph. So I'm in this area less than 3. And you'll notice that in this area, x less than 3, this is the only space where the f of x graph is less than or below the g of x graph. And that is what less than is actually finding. So what we're saying is that when x is less than 3, that is where the f of x graph is less than or below the g of x graph. That is what it's finding visually. So now we talk about greater than. If we look at x greater than 3, so that's this section of the graph, greater than 3. This is the section of the graph where f of x is greater than or above g of x. You can see that right here. This is where f of x is greater than or above. So when we're finding x greater than 3, that is where f of x is greater than or above the g of x graph. So visually, that's what's going on, is we're finding where graphs are above or below a certain point. That's what inequalities are. So let's move on and do an example where I have the graphs drawn for you. This is f of x. So this is the graph of x plus 2. This is g of x, so the graph of x squared. And we're going to start by looking where f of x equals g of x. Now we know from what we just talked about that equals means the intersection points. And specifically, we'll do the x values of the intersection points. So I find my intersection points. I have one there, and I have one there. And the x values of those intersection points are -1 and 2. So these are the x values of the intersection points. That is where the f of x graph equals the g of x graph, or is the same as. So now let's find where is the f of x graph, which is the orange one, greater than, which we just learned that greater than means above, the g of x graph, which is kind of that blue-green one. So where is the f of x graph? We're going to do blue for the g of x graph. There we go. Where's the f of x graph above the g of x graph? Well, that's right here. This is where the f of x line is above or greater than the g of x line. So we would say that's happening from x equals -1 to x equals 2. There we go. So this is the interval. These are all the x values where the f of x graph is greater than or above the g of x graph. Now, we don't know if we should do parentheses or brackets. What tells us is this sign. If it's greater than less than, we do parentheses. If it's greater than or equal to or less than or equal to, then we do brackets. So that helps us with C. In C, I want to know where the f of x line is less than or equal to, and we just learned that less than means below, the g of x line. So if I look at this graph, where is the f of x line below the g of x line? Well, that would be right here. Where's that part? And right there. This is where the f of x line is less than or below the g of x line. So if I look at those x values where that's happening, so that's all from -1, from x is -1, and then it just keeps going forever to the left. So the way we say that is from -infinity to -1. All of these x values are where the f of x line is below the g of x line. And we put a bracket because it's equal to. We say union. We also have this section. So this is from x equals 2 all the way, keep going to the right. So from 2, if I want to go to the right forever and ever, we go up to infinity and bracket because of that equal to. So that is how we find the less than, greater than stuff when you're looking at a graph visually. In the next video clip, we're going to talk about how to find these things by hand without graphing.